Hello, my name is Robin, and today I'm going to be talking about Phi-4, which was released a couple months ago. And just the model, 14 billion parameters, worked on good data. So I'm not going to be talking about Phi-4 Mini. I'm not going to be talking about Phi-4 multimodal. If you're here about that, uh, you can leave. To give some intuition, I asked three models, including Phi-4, this relatively hard math problem, which is from the AMC 12, problem 25, which is the hardest out of the AMC problems. So basically, through some reasoning steps, we all get to this value of 243, which is the correct answer. So all the models were able to do this. So that may not be shocking to you, and if not, that's like totally fine. But what it should be shocking is this. This is 70 billion parameters. That's llama 3. Quen 2.5, 72 billion parameters. Phi-4, 14 billion parameters. That's kind of crazy. So how do they do it? Did they just fine tune their model on the benchmarks by accident? You might think so, but they actually actively stop this from happening with data decontamination. So no, they did not do this. Instead of scaling model parameters, they tried to scale data quality instead. So main ideas is through very, very, very careful data set curation of organic sources, so non-machine generated, they're able to create like a seedling data set to synthetically create more structured and more for their use data. And then they were able to use reinforcement learning to employ further reasoning capabilities and safety via DPO for the models. So the basics. Why did they choose synthetic data? They just choose it as a cheap way to generate data? So short answer, no. For me, maybe yes, but short answer for them, no. Why this is converting organic data into step-by-step processes. So we want to invoke structured or gradual learning by basically creating a logical flow from question to answer. So step 1, step 2, step 3. Maybe on Stack Overflow, for example, you might get the answer first, the reasoning later, something about their mom later. Anyway, it's hard to follow, but they use language models to do this structuring. Another advantage they said that they used was inference alignment. So basically, this just means they want the model to talk in the same way that it thinks. So for example, we all know how to do this problem on the left. So y equals 2x squared, let's find the derivative with respect to x. What if we were given another problem? Y equals to 4x squared. Find the derivative with respect to x. So for us, it's very intuitive to make the connection to match this problem. And I can use the power rule to blah, 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 get your answer. So we want the model to do something very similar in the same way. So we want to do more straightforward information retrieval. Okay, I'm going to block this out. And we can talk a little bit about the model itself, or I guess like the model flow. So we're going to start off with organic data that we very, very carefully collect. Then we're going to synthetically generate our training data, which is more in a more structured fashion in question and answer form. Then we're going to train our Phi-4 model, which is basically same thing as Phi-3. And then we're going to skip some steps in between for now, and we're going to jump straight into fine-tuning via reinforcement learning via DPO. So in this step, we're going to induce reasoning, and in the next round of reinforcement learning, we're going to add safety. So that's the workflow. So step 1, seedling curation. How do we create these seedlings? So basically, the authors had 3 main areas of data sets. So web and code-based seeds. This is like archive, GitHub, basically just collections of text. And from here, it becomes a seedling if there's a strong educational potential. This is more specified in their paper. They use a classifier, I believe, to try to differentiate this. You can look more about it later. Secondly, Q&A data sets. This is just question answer. So they filter out questions that are way too easy or way too hard. So for example, this might not be, a seedling that's good for our model. So that might get thrown away. And lastly, the third one downstairs, Q&A from organic sources, essentially. So what they do is from some logical progression of text, such as in a math textbook where they're walking through how to do a problem, they generate question and answer pairs from those. Yeah. And that goes. And furthermore, we want to be very, very, very picky about these seedlings. So there's a step right before in which the researchers actually even do a preliminary filtering step for these seeds. Okay, so now we have these seeds, how do we actually generate our data set? So that's actually a quite straightforward process. Basically, researchers use GPT-4o, and if you we start off with a passage of text or a question and answer. It is at the very end, we want to have a question and answer pair that is very, very well refined. So if we have a passage of text, we're going to rewrite and augment it into question and answer form. Then if we have a question and answer, we want to revise it n times via your language model until the answer gets good enough to a degree. It is also specified in the paper to what degree this is done. So now we have our data set of good stuff. Now we train the model. So this is just pre-training, and we're trying to push as much information as we can into the model. I have no time to show this, but it's pretty stock standard, pretty general. And there's some other stuff in between, such as increasing context length. So mid-training is what they call it. So in post-training, the first step I said was we want to improve reasoning. So before we dive into details, basically what the researchers found from observing models was that when a model generates like a solution, like a correct solution to a problem, there's a few specific words of the answer. So for example, as with a derivative problem, the power rule would probably, heavily contribute to the correctness of the answer. For this problem, we're going to be doing the same thing. So, and we want the model to be incentivized to use the most important tokens. So if we are the algorithm, basically this problem is we want to isolate R, okay? So what's the best way to do this? Of course, we can cross multiply. We can multiply, or we can add both sides by something, sure. The best solution is to cross multiply here because A, it is correct. B, it gets us to our next step faster. So multiplying both sides by some constant is a very valid answer, but it's wastes some time. Adding both sides by something wastes some time. So what we want to do is we want to add a reward whenever the token basically generates a cross, assuming that's the token given this context. And we want to disincentivize the model from using the word adding with this context. And basically, this is done on the entire fine-tuning data set. And this whole process is called pivotal token search. And of course, there can be multiple pivotal tokens per context. Implementation-wise, read the paper. It gets complicated. Okay, so the second round of fine-tuning, hallucinations. So this is done from a high level, basically with GPT-4o to judge the outputs of the model and saying, hello, is this a good output, a bad output, or a maybe output? And that's pretty much it. It's kind of simplified. Read the paper if you want more details. Next, so design evaluation. Before we get into experiments, their data set is very, very, very clean. So they make sure that their data set does not overlap with the benchmark data sets. So they do data decontamination and they do data deduplication within their own data set. This is a non-trivial problem. Essentially, they get this done by creating, I believe, is an n-gram classifier, and they get rid of the matches within their data sets and overlapping ones. You can read more about it in their paper. Anyway, they also have an internal benchmark they call Phi-bench, which they use to tune hyperparameters and figure out the data mixture for their data sets. So this is like what percentage of coding data do you want, and so on and so forth to try. And they want to find the best combination. Okay, and next, basically this is the hard numbers, so metrics and results. The numbers you really want to look at, and they really, really push, is GPT-QA, which is the science data set, and math, right below it out of these models, which is kind of crazy. A 14 billion parameter model beating out GPT-4o in math. That's not really heard of these days. In general, most of the metrics are pretty similar. In the other veins of thought, in other metrics, it may not be as good as the large models. Safety, of course, because that's what they fine-tuned it for. And according to their in-house responsible AI benchmark, they do pretty well against their own models and other small models of that size. So critiques of the paper. I give a gold star to this paper for really, really having clean data and giving the intuition behind why they want to use synthetic data. And additionally, making steps to really, really make sure that the data that is generated is as clean as possible. So, great work. Some other things I have for this. I feel like the methods used in these papers may not be as good for subjective topics. So the method of data curation or pivotal token search, those may work only for verifiable domains. And I'm not sure how scalable this is. Anyway, that's probably not what they're aiming for, but it's okay. And using GPT-4 may introduce bias as a judge. I'm not sure how much. So another critique is, here's a classic problem. 9.11 and 9.99, or 9.9. Which number is larger? Phi-4 says 9.1 is larger than 9.9, which makes you think, huh? Is this really a math model or a STEM-focused model? And yeah, this is not just a problem for Phi-4. It's actually a problem amongst many models. To my knowledge, at least according to Andre Caparte, it's an issue to do with the embedding of tokens of like 9.1 and 9.9, and somehow they refer to like Bible point 11 is further ahead than 9.9, and I think that's how they came up with this number. So that's not a really fault of the model itself. Is really, really significant. As you see, Phi-4 multimodal mini were released, so they're clearly somehow connecting the dots between having really, really great quality data and having really performant models. Personal readability, I thought it was quite readable. Of course, there's like a lot to read, but there's a lot of supporting diagrams to help and pseudocode to help with the logic. And most of the paper's contents, I would say, is in the first 15 pages, not 36, as you see when you print the paper out. So that's great stuff. And my questions to you: this Phi-4 successes with synthetic data shift away from organic training data? I would say it just depends on the use case where, you know, the answers are verifiable. But if you want to create a more general model, write me an essay. Maybe this will not be as good for that. So on and so forth. Phi-4 is fine-tuned to maximize performance on single-turn queries. Are there potential applications? Like, if you search something on Google or a simple question, sometimes it'll return a language-modeled response. So for search engines, I can definitely see a benefit. And can you run this on your home computer? Yes, you can. So you can run it via Olama, or if you don't have enough GPU VRAM, you can quantize it, and there are resources to run it. But yeah, thank you.